All right, good morning and welcome back. Today we are just going to go over a few problems to make sure you guys are ready for this test. So on this first line, it says on examples 1 and 2, the lines that appear tangent are tangent. The reason that is important here is we know if a line is tangent, then the radius and that tangent line are perpendicular, meaning they form a right angle. So right here would be a right angle. I forgot to say on the example 1, but we are trying to find what is the radius of this. So what is x there? Now if we look here, hopefully you can see we have a right triangle. So we can use a squared plus b squared equals c squared. So x squared plus 16 squared would equal, now this whole length of the hypotenuse here, 8 and a 12, add them together. 8 plus 12 gives us 20. So 20 squared. We'll go ahead and square those. Use your calculator if you need to. 16 squared is 256. 20 squared gives us 400. We subtract the 256. We're left with x squared equals 144. Take the square root, and we will get x equals 12. That is what our radius is. Okay. Now, some of you might have already known that because if you look right here, there is the radius as well, right there, 12. So it makes sense. So if you could have just solved it that way, but either way, you have your answer, 12. Okay, the next one. Once again, they form a right angle here. There's one. Here's another one. We know if it's a four-sided figure, it adds up to 360. That's how many degrees there are. We have 90, 90, and 117, and a missing angle. So we can do 90 plus 90 plus 117. We get 297. Take that from 360. And our question mark will be 63 degrees. All right, example 3 here. This one has a couple different arcs, the blue and the red arc. Also, we have these two lines, these two chords, and they both have a mark on them. That means they're the same distance. If they're the same distance, they're congruent to each other. So from A to D and D to C, that's the same, which would mean that both of these arcs will have to be the same. So I can simply put 2x equal to x plus 40. From here, minus x leaves us to x will equal 40. Now it doesn't ask us for this, but if we wanted to, we could plug it in. If I plug that in there, this arc is 80. If I plug it in there, 2 times 40 is also 80, which makes sense that they would be the same. Okay. So our next one, example 4. This is what we call an inscribed angle. Hopefully you remember the inscribed angle is always half of whatever the arc is that's included in it. So it's inscribed because the vertex is on the circle. So if it's half of this, 80 divided by 2 will leave us with our question mark equaling 40 degrees. Okay, the next one. Once again, we have an inscribed angle. We are trying to find this missing angle. Or if we find this missing angle, I mean, we can find what this arc is. So in order to find what this missing angle is, first we need to remember what we know about triangles. Every triangle in the world adds up to 180. So if I take 49 plus 70, get 119, take 180 minus that 119, that gives us 61. So 61 degrees, you can put right there. Now the reason that is useful, it's kind of the opposite of the one we did last time. When we have an inscribed angle, which it might be harder to see, but if I highlight it in red here from D to B to C, and then in purple here, this arc is what we're trying to find. Remember, the inscribed angle is always half of the arc. So from the arc to the inscribed angle, we divide by 2. To go the other way, we multiply by 2. 2 times 61. So that'll be 2, 122. So 122 degrees is what our question mark will equal. All right, just a few more examples. So number 5 here, or sorry, number 6. On this one, we were trying to find this vertical angle. We know that we can just add these two together. 158 plus 80. And we'll divide that by 2. So 158 plus 80 gives us 238. Divided by 2 will equal, the question mark will equal 119. Now, that was what this angle was. No, this angle is also 119. Now, I did not ask you to find this, but I asked for either of these red angles. Those would be a linear pair with the blue one. So we could take 180 minus 119 and get 61 over there. Okay. So now, example 7 on this one. Our goal is to find out what x is. Let's first figure out what this angle is over here. So hopefully you remember from yesterday. If we subtract these, always find their bigger arc. So 130 minus this 48. And the reason we use those two arcs is because they are included in our angle. If we do that, 130 minus 48, that'll get us down to, let's see, 130 minus 48 would be 88. So then when we divide that by, sorry, I misspoke, not 88. It's going to be 82. Okay, so now if we divide that by 2, we'll get a value of 41. Now 41 would be what this angle is. We're not quite done. We got to set that equal to that. So 41 equals our 13x plus 2. Subtract 2, we'll be left with 39 equals 13x. Go ahead, divide by 13, x will equal 3. All right, our final problem. There are numerous ways we could solve this. First thing I want to point out, though, I think the easiest way, in my opinion, is we have a diameter here. Cuts straight through the center, goes across. If that is the case, this means we have a semicircle, which is 180. So all we need to do, 28x plus 6 plus 15x plus 2, we add those two together, we will equal 180. Combine our like terms, 28x plus 15x, that gives us 43x, 6 plus 2 plus 8. Subtract that 8. $43x equals 172. We divide by 43 and we will get x to equal 4. All right, that's all for today. Let me know if you need any help. Happy to help you. And make sure we get the test done before break. It will go live today at 3:30. If you're not ready for it, wait to take it. Just get it done before break. Hope you guys have a great day. Bye.